Let's continue to talk about our approach for this week, how to reduce the runtime for DVC scheduling. The first thing, like I say, about the subject code part, we have no change because here we do the for loop, nested for loop sorting. Even the runtime is n squared, but you see the n is less than 200, so it's not a bottleneck for our runtime. So instead, I want to focus on here for the duplicate check. At the end of previous video, I talked about, in our assignment 5, we have the for loop, we have the n squared runtime. But here the most important thing is, in the duplicate check, our for loop, we process all line with the class code. That's the term plus section. So that's why we have the n at the end, almost non-duplicate section will be 86K. So that's cause our runtime n squared is very big because your runtime is n squared and your n is greater than 86K. That's why your runtime is slow. Remember, algorithm is algorithm. Your algorithm result is n squared, but the reflect is according to the number of n. If number of n is small, n squared, n log n, constant number, their runtime doesn't have that big difference. But one thing is here, when your n squared and your n is big, then the runtime will be significant large. So that's why we're thinking about how should we do the duplicate check easier, or we say faster, more efficiently. Earlier, we always have the class code. We check turn combined with the section. So now let's think about the other way. I know we need to have the turn and section match, that's the duplicated. So how about we don't combine class code, we're just using the turn. So we check the turn first, then we check the section. So if they both match, that also is a duplicate. And also we find out actually if we group the data with the term first, in the past 20 years, actually we just about 60 semester. So that's why your n is 60, then you finish the turn check. Then about the section number. In the past 20 years, we have almost 90,000 K. So divide by 60 turns. So then about one semester, we're about less than 2,000 section. And also when we do the term first, then we check section. Actually, this one is not nested for loop. They are a loop after another loop. So that's why here the runtime combined together will become plus. Okay. So remember, you see, you have the term first, right? So you have the for loop for I equal to 0 less than 60. When this one is true, okay, I check the next one. So then we check the section. So the section is about the same thing again. That will be another for loop, 0 to less than 2,000. So these two actually, they are not nested for loop. They are the loop next to each other. I check this one first. After I find that, I do this. So that's why you are checking time inside the while loop. So before this for loop, n equal to 86K. But now here, when we add together, this n actually is n here estimate equal to the 60 plus 1500. So the same thing is under than 2,000. So that's why you can see here. Even they are still inside the while loop. But here, while loop, you see we process how many lines we cannot change. We always need to process this 89,000 line. But here, if the duplicate check, instead we do the class code, n equal to n greater than 86K, or we do the term first, then section. Actually, our n become less than 2,000. So actually, this runtime comparison Okay, so I want to show you the runtime comparison from assignment 5. And this week, so that's why I want to show you the runtime comparison for our assignment 5, DVC schedule V1 and DVC schedule V2 in assignment 6, what you will implement this week. So the difference is, remember, the outer loop we cannot change. Now we change the algorithm is the duplicate check in the inner loop. In the inner loop in your V1, your N is greater than 86,000. But in your V2, your N is less than 2,000. So on the other hand, we get rid of the 0, 0, the 3, 0. So that's about 43 ratio to 1. So runtime ratio will be 43 to 1. Okay, so on the other hand, if you spend 43 seconds, just say for example, 43 seconds in your V, so this runtime ratio will just simplify as 43 to 1. So on the other hand, if your runtime in V2 is 43 seconds, then you only need 1 second to finish in V2. But in your V1, we just say not everyone finish within 1 minute, right? So that's how we see, no matter what, you say you finish with 3 minutes. So 3 minutes, maybe we just say this time times 4. So then you see in V2, you will finish in 4 seconds. Okay, so that's the runtime we are expecting for. But next question is, how should we check the term first? Then we do the section. So that's actually is your lab exercise I want you to discuss with your classmates before I will show you how to do that. But here, I just want you to think about, do you kind of okay with the runtime when we say that? Okay, so then we see from V1, you see check classCode, term plus section. N will be greater than 86K. But now, when we do the term first, then section, you agree with me, actually our comparison will be less than 2,000. So that will be make our runtime changed in our V2. So take a break to see if that's good for you. So after you are all okay with that, understand our algorithm for the V2 and how the runtime we are expected to change. So now I want to explain to you, how should we do that? So that's me copy this. For loop. So then now we don't need this. Okay, we don't need this because we already decide we don't do the class code and the section. But here, one thing we do is we will do when we do the duplicate check, we will do term first, then section. Okay, so now we need to think about what mean term first, then section. So on the other hand, in order to find the term first, then you do section, you need to find the correct term that you need to check the section. So on the other hand, now actually we need to change a little bit our object, how we will save in our dynamic array. Before in our dynamic array, because we have the class code, so that's why our non-duplicate classes we're using for string. That's the class code equal to term plus section. But now since we need to check the term first, on the other hand, I need to find, for example, my term is spring 2001. Okay, so then after I match, spring 2001, I find that. Then I need to check under that spring 2001, do I have my current section exist? Right, on the other hand, did you notice? Actually, when we check the term first, then the section, that means when I check the term, that object should contain what section within that term. Right, so that's why here, actually, we need to introduce you. Actually, we need to think about one way. You don't need to follow what I have demonstrated in the reading page or the lecture. But you need to think about, since we want to check the term first, then section. That means turn and the section, they have the connection, right? So that's why, right? So then we need to create an object including the turn and including the section information. So let me show you actually what I say is look like this. Remember earlier I said I want to check the term first. Then I see that section exists or not. So that's on the other hand, you will see here. Let me draw that. Okay. So this one actually is one object I was searching for. So in this object, the first thing I have the term information. Then I have section information. So the same thing, this one is for the 2003 term. So far they have 3 sections. So then the same thing, you see I have another object. So this object, you see each object, they need to contain what? They need to contain the term information, then all the section information. So then you see another one, the same thing, term information, summer 2009, then the section information. So that's why you can see here, we have the term information will be a string, right? So that will be the one data attribute. Then you see the section. Section is a 4-digit number. We can either treat them as digit or we treat them as a string, either way you decide. But those sections, actually, they kind of need to group together because they are one by one. Did you get what I say for the term and the section object? Good. So then we need to think about what kind of object I should declare. Did you remember last week when we do just like the subject, you have subject code, then you have a number. So now actually we need to have another object we did create. I need to have the terms information, then I have the section number. Okay, so that subject I talked about earlier, you see we need to have the term, then section, right? So that's the subject we need. So this subject we call the sections for terms. So let me see, I put here. Okay, so then you can see clear. So that we call the section for terms. Because each object I have the terms, then the most important thing I need to have section. So that's why I see I have the string is a term. Then you see earlier we show you see the section. The section there we need to group together. So then how about we give them another array, we group them together. So of course this array, like you say, either array, dynamic array, static array, your decision. Okay. So one thing is static array, you need to know exactly the number or the roughly idea. So since here we're not quite sure the section, how many section will be in the each term. Because even we say averagely they are being 1500. But you know, because the past 20 years, maybe the beginning we don't have so many sections, so later we grow. So that's why in this section for terms object, does have another dynamic array. This one we call the sync section number. Or you see the purpose for this, the name you can decide yourself. But the purpose is I want to save all the section number one by one in this dynamic array. So here we choose a string because string we are easy to do the comparison. So then we do the string for 4-digit string. Okay, so that's our section for term. So this section for term is what? Because earlier, like we said, we need to find the term first, then we find the section. So that's why they need to group in one object. So that's why we create another struct we call section for term. So we have the terms and then we have the section number in an array. So did you see this one actually very familiar? This kind of like the subject code we have last week, but now this one we have is for the section for term. As for each term, we have the term name and we have the array for the section. So that's why after you understand this part, so later you will see here my duplicate check, my flow chart will change a little bit. So check, do you have question for here? So then later we can make the change for our non-duplicate class. Or you can guess, right? So here actually our non-duplicate class, the data type change becomes section for turn.